If you do A-level PE and you're struggling with the Bohr shift, listen up to this. So the Bohr shift is when this oxyhemoglobin dissociation curve shifts to the right, like so. And you would always get credit in the exam for mentioning that. It's when this oxyhemoglobin dissociation curve shifts to the right. And it happens due to an increase in lactic acid, CO2, or body temperature. And when those conditions occur, this lowers hemoglobin's affinity for oxygen, and affinity just means attraction. So if hemoglobin's attraction or affinity for oxygen has gone down, it means that it's going to be able to dissociate with even more of it. So hemoglobin dissociating with oxygen is when it lets go of it. So because it's now got a lower affinity for oxygen, it's now able to dissociate with even more of it than usual, and that just makes even more oxygen available to then diffuse into the muscle cell. So let's say that this is a muscle cell here and this is the capillary. If hemoglobin is dissociating with even more oxygen, it means that it's letting go of even more than it usually would at rest. And that is a good thing because now that oxygen is available to diffuse out of the capillary and into the muscle cell. And if we look at this curve now, going up to the normal line, it was saying that in that amount of oxygen, hemoglobin would usually be 75% saturated with oxygen, which means that hemoglobin would still have 3 out of its 4 oxygens bound to it, so it would only have let go of 1 oxygen there. However, if we work up to the Bohr shift line, that's now saying that instead of hemoglobin being 75% saturated, it's only 25% saturated now. So that hemoglobin would look like this. It would only have 1 of the 4 oxygens still bound to it, and it would have dissociated with the other 3. So the Bohr shift itself on the graph is just trying to illustrate these points here, that during exercise, hemoglobin is dissociating with even more oxygen than it usually would. And that is a good thing because that oxygen is now available to diffuse into the muscle cell.